Hello everyone, welcome to our CS584 project presentation. We chose option 1, which is auditing for bias. My name is Susanna Rafi and my partner's name is MD Nishat Raihan. So the problem given in the project is that based on a publicly available dataset of criminal history, we have to predict whether a defendant in a criminal case will recidivate within the next 2 years or not. Then we have to analyze if there are any biases based on the race feature. We also have to train a model with and without the race feature and compare the results. Finally, design a fair model that does not have any bias on the race features. So, as for the dataset, we worked with one of the variants of ProPublica Compass dataset, which contains 53 features and 7,214 instances. It contains features such as criminal history, jail and prison time, demographics, and Compass risk scores for defendants from Broward County. Among the 53 features, we had to choose the most relevant ones, and we omitted the ones based on what we thought that a model should not be trained on, such as names, date of birth, etc. We have tried with multiple number of features, but had to be careful not to overfit the model. Based on multiple experiments, we finally picked 9 features to train our model. Model selection. We chose logistic regression to train our model. We first split the dataset, keeping 1/3 for testing as suggested. We then trained a logistic regression model where we chose the solver liblinear. Liblinear is recommended for small datasets, and based on the number of records we had in our dataset, choosing liblinear was justified. We chose a max iteration of 15,000. The accuracy of our model was 97.14%. The next part will be presented by my partner.
So we observed some significant biases in the model. The accuracy was 97.14%, as we mentioned before. The precision for our model was 94.72%, and the recall was 100%. To answer the first 2 questions from the project outline, we had to calculate 2 metrics. The first one being the opportunity cost. In this case, given that someone did not recidivate, we calculated the probability of them being predicted positive by our model. For all the races, this value was 5.05%, but when we set the race feature as African American, it rose to 7.39%. And for Caucasian, it climbed down to 3.93%, meaning that our model is clearly biased against the African American for this metric. The second metric was calculating bias by comparing calibration. Given someone was predicted positive by our model, we had to calculate the probability of them actually recidivating or not. Well, this value for all the races was 92.6% and also did not change much when we set the race for African American or Caucasian. So out of these 2 metrics, the opportunity cost should be the one of concern since it clearly measures the bias in our model. Now we retrained our model while keeping the race as a protected feature. In this case, we had to sacrifice some of our accuracy as it went down to 95.13%. The precision this time was 93.07% and the recall remained 100% like before. Now when we calculated the same 2 metric as mentioned in the previous slide, the results were almost similar with no significant changes in any of them. Both of them remained almost consistent even when the race feature is treated as a protected one. Finally, we had to design a fair model. For this purpose, we used the FairLearn library. And our goal was to remove the bias that is based on the race feature. As for our FairLearn model, we used the exponential gradient, and for the constant, we used the demographic parity. Also, there are some built-in standard metrics that come with the FairLearn library, which helps us to calculate biases in the model. For this metric, we chose the selection rate, which helps us to calculate the percentage of times the model predicts positive for a specific group. Now this value was 56% when the race was selected as African American and 41% for the Caucasian for the initial model that we designed before. But after FairLearn was used, these 2 values were more or less the similar, 48% for African American and 47% for Caucasian. A few takeaways to conclude this project. There will be a certain amount of bias in the model when trained without taking biasness or fairness into account. Also, among the two metrics that we calculated, opportunity cost should be the one of concern in this specific case instead of calibration. And there will be no significant differences in the results when we keep race as a protected feature. But in case of using FairLearn, we were able to generate a model that was a lot less biased than the initial one. Thank you.